Good morning, sir and ma'am. I am G. Vijay Chandra Prasad. My roll number is 2295180117. Subject Geotechnical Engineering. My topic is about experimental study on effect of waste plastic bottle strips in soil improvement. Introduction to the study. Point number 1. Presentation explores the experimental study on the effect of waste plastic bottle strips on soil improvement. Point number 2. Waste plastic is growing environmental concern and innovative solutions needed to manage it. Point number 3. Utilizing plastic waste in soil improvement can potentially enhance soil properties while addressing plastic pollutions. Background on soil improvement. Point number 1. Soil improvement is essential for enhancing agriculture productivity and ecosystem health. Traditional soil amendments include organic matters, fertilizers, and minerals can be resource intensive. Point number 3. Incorporation waste materials like plastic strips offers a sustainable alternative to conventional methods. Research objective. Point number 1. The primary objective is to assess the impact of plastic bottle strips on soil physical properties. Point number 2. Secondary goals include evaluating the effect on soil moisture retention and microbial activity. Point number 3. This study aims to contribute to sustainable waste management and soil enhancement practices. Methodology overview. Part number 1. A controlled experimental setup was designed using various soil samples with different plastic strips concentrations. Point number 2. Soil samples were analyzed for physical and chemical properties before and after introduction of plastic strips. Data were collected on moisture retention and compaction and microbial diversity over a set period. Preparation of plastic bottle strips. Point number 1. Used plastic bottles were collected, cleaned, and cut into uniform strips for the experimental the experiment. Point number 2. The size and shape of strips were standardized to ensure consistency across experiments. This preparation process aimed to minimize potential variance in the experimental results. Experimental design. Point number 1. The study employed around randomized block design with control and treatment groups for comparison. Point number 2. Different treatments included varying percentage of plastic strips added to the soil mix. Point number 3. Soil properties were monitored over several weeks to assess changes and improvement results on soil physical properties. Point number 1. The introduction of plastic strips improved soil aeration and drainage compared to control samples. Point number 2. Soil compaction was reduced, allowing for better root growth and water infiltration. Point number 3. Plastic strips also contributed to the more stable soil structure, enhancing its results. Results on moisture retention. Point number 1. Soil with plastic strips exhibiting significantly higher moisture retention compared to untreated soil. Point number 2. This increases in water holding capacity can benefit plant growth during dry conditions. Point number 3. The presence of plastic strips helps mitigate evaporation, preserving soil moisture. Effects on microbial activity. Point number 2. Point number 1. Microbial diversity was positively affected by the incorporation of plastic strips in the soil. Point number 2. An increase in beneficial microbial populations was observed by indicating enhanced soil health. Point number 3. The microbial activity play a crucial role in the nutrient cycling and soil fertility. Conclusion and future work. Point number 1. The study demonstrates that waste plastic bottles can be effective in improving soil properties. Part number 2. Further research is needed to explore long-term effects and potential applications in the different soil types. Point number 3. This innovative approach could pave the way of for sustainable waste management and agriculture practices.